We have looked at right angle triangles and how to determine size and angles in them. If you have a triangle that is not a right angle triangle, as in the diagram here, triangle ABC, this triangle is not a right angle triangle. So to determine a side or an angle in it, we will either use the sine rule or the cosine rule. And so let's go ahead and look at the sine rule. First of all, let us name the angle here as angle A, the angle here as angle B, and the angle here as angle C. Then we will also name the size. The side opposite angle A will be labeled as small a. The side opposite angle B will be labeled as small b, and the side opposite angle C will be labeled as small c. Also, we will draw a perpendicular line from A to meet BC at D. So I'll label here as D, and that is a perpendicular line. Now, this perpendicular line is the height of the triangle. That said, if I want to find the height of this triangle, I now have the opportunity of using right angle triangle, because if I look at triangle ABD, it is a right angle triangle. Also, if I look at triangle ADC, it is also a right angle triangle. So from either side, I can find the height. Okay, so let's do that. So I will start with the triangle ABD. So sine B will be equal to H over C. And if I make H the subject, then I'm getting C sine B is equal to H. That will give me equation 1. And then I will also use triangle ADC, and that I'll have sine C is equal to H over B. Again, I'll make H the subject, and that will give me B sine C is equal to H. Then I'll label it as my equation 2. So H in equation 1 is the same H in equation 2, which means, so that implies that B sine C is the same as C sine B. Now I will divide both sides by BC. And if that happens, this B here cancels the B here, and the C here also cancels the C here, giving me sine C over C is equal to sine B over B. And that is the sine rule. So the sine rule applies to all the sides and their opposite angles. That is to say, if I have sine A over A, the ratio should be the same as sine B over B, and which is also the same as sine C over C. The reverse is also true. So we can rewrite it as the side over the angle, sine of the angle, so this is the sine rule. Okay, so we are looking at the cosine rule. I have labeled the triangle as we did in the sine rule. But in the cosine rule, we are interested in finding the length. Okay, this side, the D, the point here is D. We are interested in finding the length of BD and then the length of DC. And so we are going to represent the length BD with M, and then the length DC, we know that BC is A. So if BD is M, then when we subtract M from A, the remaining will be the length DC. So A minus M here gives us the length DC. I hope this is understandable. Okay, so let's continue from there. Now I'll use the Pythagoras theorem on triangle ABD, and that gives me C squared is equal to M squared plus H squared. I'll label that as equation 1. Then I'll take triangle ACD and also apply the Pythagoras theorem. That gives me B squared is equal to A minus M in brackets squared plus H squared. That becomes my equation 2. Now I will subtract equation 2 from equation 1. And if I do that, I'll get C squared minus B squared equal to M squared minus A minus M squared in bracket, and then plus H squared minus H squared. And so H squared and H squared are like terms, and with a minus we can subtract. And then with that done, the remainder is C squared minus B squared is equal to M squared minus A minus M whole squared. Now I will expand the binomial in the brackets to, so when I do the expansion, I'll get A squared minus 2AM plus M squared. I will also open the brackets. Now look at M squared and M squared, they are like terms. So M squared minus M squared will cancel themselves out, with C squared minus B squared equal to minus A squared plus 2AM remaining. Now, from triangle ABD, I will use cos. So I will find cos B, and that is adjacent, which is the M, over the hypotenuse, which is the C. Now I'll make M the subject and obtain C cos B. Okay, what I wanted to do is to replace the M in this expression so that everything will be in terms of ABC, not any M. So if I replace, it becomes C squared minus B squared is equal to minus a squared plus 2ac cos b. C cos b. So that's what I get. So if I open the bracket, I will have it as c squared minus b squared is equal to minus a squared plus 2ac cos b. Okay, now I will rearrange them and have it as b squared is equal to c squared plus a squared minus 2ac cos b. And that is what we have as our cosine rule. And this can be replicated for all the other sides. So for side a squared is equal to b squared plus c squared minus 2bc cos a. And for the side b, we have b squared is equal to a squared plus c squared minus 2ac cos b. And then for the side c, we have c squared is equal to a squared plus b squared minus 2ab cos c. And that is it for our cosine rule.